Right, there are a lot of challenges making a good touchpad. For example, there's different sizes of fingers. People, rest their thumb on their, touchpad, and we have to negate that in our driver. We also have a wide set of gestures, with pinch, rotate. With Windows 8, we have all the edge swipes. So those are some of the things. We also have funny things like people, have lotion on their finger, and we have to try to, negate how that works. Some say it's really hard to click, some say it's too easy to click, and sometimes it's not consistent over the touch surface. We actually have designed our own hinge that allows the best experience that Synaptics thinks that the user should be able to have, and that's our ClickPad 2.0. And so we're promoting that here at CES as well. Well, our ForcePad has a great, best-in-class Synaptics touchpad that have been shipping on the market for years, but it's actually integrated with force sensors. So we can use 5 fingers, and we can detect the force of each finger. And that's actually cool because we can do things like scrolling, where you can press harder to go faster or press slower to scroll slower. So it has this precision scrolling, and style that you can do with the touchpad. And with ThinTouch, we actually recently acquired a company in June that has done ultra-thin keyboards. So we have actually, added our capacitive sensors to the keyboard, and we can actually get so much more data, and we can do a lot more cool things with the sensor and the keyboard together. The feel is really important to our users. They want something that's consistent, not one edge is a little lower than the other. So it's very important to have this hinge, which is why Synaptics has done all this research to see how many newtons of force we should have and everything like that.
Well, Synaptics is, as you may be familiar with, the first provider of touchscreens for mobile handsets. We were in the LG product, which was the very first capacitive phone with a touchscreen in it that was launched back in 2007. And now we are offering products that span the entire range of smartphones, from the value segment, for developing nations as well as China, as captured with our Samsung Galaxy Music phone, all the way into the high-end premium offerings, which are typically implemented in discrete sensors with our Series 3, or in a variety of other form factors like our on-cell and in-cell, which would be characterized by our Sony Xperia P. For the first time, end users will actually be able to see the benefits of superior touch performance in the form of a new end user feature, and this is the gloved operation that is highlighted in the new Nokia Lumia 920 handset. The act of actually being able to sense the glove itself was not all that difficult. The difficulty was involved in trying to figure out when to turn on the special mode to detect the glove and when to turn it off, because obviously when you take your glove off, you don't want the phone to be activating, with a super sensitive touchscreen sensor. Certainly are seeing a lot of interest in this type of gloved operation, which also incidentally allows you to use a stylus, as far as like a pencil or any other conductive pen. That is all provided within our controller chip, and part of the magic, if you will, of our chip is that we do have the algorithms embedded within our controller to enable the detection and the automatic switching of modes between a finger detection mode as well as a pen/glove detection mode. The development board is a kit that allows media to be able to evaluate the different performance functions of the touchscreen sensor. So from the software side, it allows you to visualize the multiple touch points as well as make some basic measurements for linearity.